So yesterday in class, we talked about looking at numbers and figuring out, based on the number, how accurate the tool was that was used to measure that number. So the different things that we use to measure things in the lab, depending on their increments or if they're digital, what decimal place they read to, different numbers tell us something about that accuracy. So significant figures is a fancy way of saying how many numbers or how many digits are in a number, in a measurement that you take. So when you're counting, when you're looking at a number and you're trying to decide how many significant figures it has, if the number doesn't have any zeros in it, that's easy because all numbers that aren't zero are significant. So if we look at the first example, I have 432. There are no zeros in that number. So I can just go ahead and say, okay, how many numbers are there? 3. So there are 3 significant figures. My next example has a 0 in it. So now I have to pay attention to the other rules. So rule number 2 says when there's no decimal, the ending zeros are not significant. They don't count. They're placeholders. Okay, so see how there's no decimal in that number? That means that the 7 and the 3 are significant, but that ending 0 is not. I don't count that as a significant figure. So there are only 2 sig figs in that number. Now, if I look at 65.0, this number also ends in a 0, but there is a decimal there. So because there is a decimal there, the ending zeros are significant. So how many sig figs, how many numbers are in that number? There are 3. Okay. So the question is going to pop up in the Edpuzzle. I want you guys to figure out how many sig figs are in 8400. Okay, so now that you've answered that, hopefully you answered that there are 2. So if I look at this number, it has no decimal, so the ending zeros are not significant. Those 2 zeros at the end do not count. They're placeholders. So the tool that we used to get this measurement wasn't accurate enough to put a decimal place at the end. Okay, so the third rule, now this number is a little bit different because it has a decimal in it and the number is smaller than 1. So the third rule says that when there is a decimal, the beginning zeros are not significant. So even though in a number like this, I counted the end zeros, in a number like this, the beginning zeros are not significant. So I wouldn't count those first 3 zeros. Those are just placeholders. How many numbers do I have after those first 3 zeros? I have a 4, a 5, a 0, and a 1. So I have 4 sig figs. Okay, so I'm going to pop some questions in the Edpuzzle. I want you guys to figure out how many sig figs are in 0.850 and in 101.0. Okay, so hopefully you've answered 3. When the number is less than 1, the beginning zeros are not significant, but the rest are. The ending zeros are. And for this one, you should have gotten 4. So there is a decimal here, and the number is bigger than 1, so there's no beginning zeros to not count. The ending zeros do count. Okay. If this is confusing to you, trying to remember like where the zeros are and when they count and when they don't count, there's a nice trick that you can use. And if you decide that the rules don't make sense and you want to use this trick, that's fine for me. So you need to kind of know what the United States looks like. This is my rough sketch of the United States. You can just draw a square, that's fine. I want you to think about what ocean is on the left side. Pacific. So let's put a P there. And what ocean is on the right side? The Atlantic. So we're going to put an A there. So why is a P and an A important? The P stands for there is a decimal present in the number. And the A stands for the decimal is absent in the number. So either you're looking for a number with a dot in it or a number without a dot. If the decimal is present, you count from left to right. You count the numbers in a forward direction. If the decimal is absent, you start at the end of the number and you count the numbers backwards. Now you're probably thinking, whether I count forward or backwards, I'm going to get the same amount of numbers. So here's the important part. You're never allowed to start counting at 0. Oops, sorry guys, hold on. Counting at 0. So you're either counting forwards or backwards, and you can never start counting at a 0. So let's look at the first example. I have a decimal present or absent in that number. I see that the decimal is present. There's a decimal right there. So that means that I need to count the numbers left to right. But I can't start counting at 0, so I can't count that. I can't count that. Now I got to a 6. 6 is not 0, so I can start counting at the 6. Once you start counting, you count all the way to the end of the number, whether there's zeros there or not. Everything counts once you start counting. So how many numbers are there? 4. So that number has 4 sig figs. For my second example, the decimal is absent. There's no decimal point in that number. So that means that I would count this number backwards. But I have to remember my rule that I can never start counting at 0. So I can't start counting here. I can't start counting here. I can start counting at this 3 because it's not a 0. Now, once I start counting, I have to count all the way to the end of the number. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7. So this number has 7 sig figs in it. Okay. So whether you're using the rules or this trick, either way will determine how many sig figs are in a number. Okay. So now, why is this important? We've been doing a lot of calculations, and you guys have been getting these crazy answers in your calculators, and you've been asking me what you need to round to. And my answer to you was, right now you can round to whatever you want. Now that you know about sig figs, you're not allowed to round to whatever you want. You have to follow the rules for rounding according to the sig figs in the numbers that are given to you in the question. So whatever operation you're doing, multiplying and dividing or adding and subtracting, there are different rules. So when you're multiplying and dividing, you want to round to the lowest number of sig figs. So your answer should have the lowest number of sig figs in it that's given to you in the question. So let's just do an example together and we'll see. So I have 127.4 and I'm dividing by 2. So when I do that, I get 63.7, right? That's what comes up in my calculator. Now I need to go ahead and look at the numbers that I was given. How many sig figs are in 127.4? 4. And how many sig figs are in 2.0? 2. So what's the smaller number, 4 or 2? 2 is my smaller number. So that's telling me that your answer is only allowed to have 2 sig figs in it. Right now, it has 3 sig figs in it. So I want to round this answer so that there's only 2 numbers showing. So I basically want to get rid of this number that's in the 10th spot. And I can't just get rid of that. I have to round appropriately. So since the number in the 10th spot is bigger than 5, what has to happen to my number that's in the 1 spot? It has to round up. So what the right answer would be to this question is 64. I have 2 sig figs. Okay. Now with multiplying, it works the same way. If I do 7 times 2, I get 14, right? But if I look at what I'm given, 7 has 1 sig fig in it, and 2 has 1 sig fig in it. So how can I round 14 so that it only has 1 sig fig in it? I can't just like erase the 4. 14 and 1 are not equivalent to the same number. You want to round to the 10 spot. So if I'm at 14, I could either round it down to 10 or I could round it up to 20. What would make the most sense? Since 4 is less than 5, I would round this number down to 10. Okay? Or you could always write in scientific notation as well. I can do 1.4 times 10 to the first power, but this still is going to have 2 sig figs in it. So I would end up just writing 1 times 10 to the first power anyway. And if you write that out in standard notation, you get 10. So you could always use scientific notation too if you're having trouble trying to round it to make the number have the right number of sig figs. Okay, adding and subtracting has slightly different rules. You're going to add or subtract whatever the question is telling you to do. So here they're telling me to subtract. So when I subtract those 2 numbers, I'm just going to draw it over here so that I have more room. When I subtract these numbers, I get 1.356. Okay. So now what I need to do is not look at the total number of sig figs in the numbers. I just need to look for how many numbers after the decimal there are. So this number has 3. It's to the 1,000th spot. And this number has 1. It's to the 10th spot. But the same idea as multiplying and dividing, you want to choose the smaller number. So the smallest number is 1 decimal place. So my answer should be rounded so that there's only 1 number showing after the decimal. Okay, so I would round this to 1 point. The number that comes after the 3 is a 5, so that would make me round up to 1.4. So it's kind of like you're only as strong as your weakest link. Your answer can only be as accurate as your least accurate measurement. Okay, so we're going to do a lot more practice with this in class, and you're going to do some on your own now.